Okay, so in this video, we're going to be talking about variables and experiments. I guess another way you could think of this is like some basic research methods concepts. So obviously, being a research methods class, we're going to have a heavy bias towards the scientific method. For what it's worth, in future iterations of this course, I plan to incorporate other types of research or other types of research methods, such as indigenous research, things like that. Maybe more of a qualitative focus. Um, but for now, let's just refresh our memory real briefly on what the scientific method is. And actually, I'm not going to spend time on this. Y'all have probably encountered this throughout your education. So this is one way of kind of depicting it, but there's honestly lots of different frameworks out there, but they all kind of have the same general premise in recognizing that this is an ongoing process. As we build new knowledge or generate new knowledge, rather, then we use that to continue the research cycle. First, let's talk about variables. I guess now that I'm recording this, I'm realizing I don't explicitly define variables. Variable, broadly speaking, you can think of as anything that varies, meaning that we could have some different response, whether that's a number or yeah, I guess I'll cover that in a sec, or something that's more like word-based or content-based. Continuous versus discrete, I wouldn't say is super important for this class, or at least not at this point in time. But for what it's worth, continuous means we're measuring something along a continuum. So basically, like one example there is an Olympic sprinter's time to finish a race, right? Like 3:54. I feel like that was like the first sub 4 minute mile. I don't know if that matters. I think that was in Kansas for what it's worth, where I'm from. But so anything that's based on a number, right? It could be 16, I don't know, units of something, whatever it may be. Discrete. In this case, we're basically dividing things into discrete or explicit separate categories. So in this, we're usually using whole numbers, sometimes zero, but for example, being college students, if you think about like your class in college, I'm sure there's probably another term for that. But like one could be fresh person. I assume that's the term nowadays, or first year. Two could be sophomore or second year, so on and so forth. So kind of grouping things rather than having it on a continuum. Quantitative versus qualitative, what I was getting at earlier. Quantitative, if you think quantitative quantity, like the quantity of something. In this case, a variable varies by some sort of amount or a number. Qualitative, you think like the quality of something. In this case, it varies by form or class, like letters. Yeah, I guess probably poor choice of words. That's not to be confused with discrete. Discrete, we're still using numbers and we're categorizing things. I think a better term there would be like content. So, for example, if I'm asking people what their experiences are like in their first year of college, and I get a bunch of interview data, that'd be an example of qualitative data or qualitative variables. Um, if you ever need a trick to think of the difference, what I think about is if you think like you buy some bananas from the store or whatever your fruit of choice is, you'll have a certain quantity of bananas, that's the number, or of whatever fruit it is, and then the quality, sticking to bananas, the quality of the bananas would be something that's a little bit more specific to those unique bananas. The ripeness, all sorts of different stuff, right? Something that's a little bit harder to measure quantitatively, but that we could describe using language. Something from a stats class if you want some more examples. So I just wanted to show you that. Constructs, kind of like a variable, kind of not. This is kind of I'd say a little bit more of a fuzzy term, but it's one that you'll encounter a lot in research, at least in psychology and the social sciences. I think of this as like a social construct, meaning that these are things that we identify and labeled as a species. So, for example, like love, um, in the bottom bullet point there, our definitions of this can vary, right? So it's something that's socially created. Like we all have some understanding of it, but if you ask a million different people, there's going to be a lot of different ways they describe it, and there are different kinds of love, right? Like I don't know, I love my cat differently than I love my partner, differently than I love my parents and my siblings, differently than I love my Sharpie pen that I use all the time, right? Like there's different kinds. So constructs is something that's socially created. And so whenever we're doing research, we need to use and create operational definitions. Basically, this is a clear definition of the constructs in the study and tells how it will be measured. So for example, in my field, we talk about like burnout a lot, right? So we'd want to very clearly state what we mean by burnout because there's different ways we could interpret that. Some people might think of it as just being tired. Some people might think of it as more of like a long-term chronic almost illness or health problem, right? There's different ways we could define it. So we need to state what it is and then how we're going to measure it. In terms of research methods, three common research methods: experiments, quasi-experiments, and correlations. Correlations we've kind of already covered. But starting with experiments, in experimental design, one benefit is that it lets us assess cause and effect. We need a high level of control to isolate cause and effect, especially when it comes to human beings. Like if I'm trying to measure the effect of like sleep quantity on, I don't know, cognitive awareness or performance or something like that, or driving ability. So yeah, let's say we want to do a study to see if how much sleep we get affects our ability to drive. Because if you think of times like when you've been really sleepy and it was harder to drive, you're not really as awake, you're not really as aware. To really study that in a cause effect manner, we would basically have to assess people's sleep habits and driving habits in a highly controlled, highly structured environment. And this is something that's done, but it's hard to do and takes a lot of money because you're basically like asking people to stay in a room for like a week and then follow their experimenters follow them as they're going about their day and stuff. Um, so yeah, I guess the point I'm trying to make there, it's hard to do true experiments in psychology research, but it's something that can be done. Um, and in any sort of experiment to sort of isolate the cause effect relationship, we have to manipulate certain things like independent variables or IVs to see how they affect other things, dependent variables, DVs. These, it took, like when I was a student, it took me forever to kind of get these down. My mental trick: dependent variables depend on the independent variable. So the independent variable you can think kind of stands alone, and in our cause effect, we're seeing how that independent thing causes some sort of effect on the dependent variable. Um, to be an experiment, some requirements: manipulation. So we have to intentionally vary or manipulate levels of the independent variable. I'll kind of explain that with an example in a sec. Randomization, meaning that um, if we have some population, which I guess the true population for psychology would be all of humanity, um, a truly random experiment would be that every single human being on Earth has an equal chance of being selected into research groups. Obviously, that can't be done. So usually we have a smaller population. Like for example, if I'm doing a study on burnout in college students, then my total population would be like college students at UAF, for example, and then we get some sample from that, and all the students at UAF have equal chances of being selected. And some sort of comparison or control group. In this case, typically the independent variable equals 0. So to use an example to explain this, let's say we have a research question of if cardiovascular exercise influences depression, right? So like if someone's depressed and they're running, are they going to feel less depressed? Do people who exercise a lot, like running, biking, skiing, whatever it may be, are they generally less depressed than people who don't do that? So on and so forth. Um, and so in this case, I guess I should have asked you to guess this. So to give away the answer, the independent variable here would be exercise. The dependent variable is depression, right? Because we're seeing how exercise influences depression, how that depends on or is influenced by exercise. And in order to do this well and really assess this relationship, we're going to break our sample up into three different groups. So let's say we have one group who runs 1 hour a day, one who runs 30 minutes a day, one who doesn't exercise, right? They're couch potatoes. Um, I mean, no offense, I haven't ran in God knows how many years. Um, but the group that's running, we call those the experimental groups. The group that's not running, we call the control group. So using that previous idea that the IV equals 0, this is what I mean by that. The control group doesn't have some sort of effect, no manipulation, basically because we want to see like some differences here. Does running 1 hour a day, does that have more of an effect than running 30 minutes a day? But we also want to see if there's a difference between this manipulation and people who aren't exposed to this condition. So that's a brief overview of experiments. Quasi-experiments, really similar. It's just an imperfect experiment is one way to think of it. Um, these are really common in like my world workplace psychology. Um, and so in this case, there's something that's imperfect about it to where it's not a true experiment, but it's still an attempt to assess cause and effect. So for example, we might have a non-manipulated independent variable, lack of random assignment, or lack of a control or comparison group. So for some examples, say I had a question about, do genders differ in number of aggressive behaviors, right? Or not aggressive behaviors in general, right? That's my way to attempt to like quantify it. Obviously, we can't randomly assign people to different genders because someone's gender identity is unique to them, right? It's not something that a researcher could just come in and basically say, hey, you're a woman, you're a man, right? Whatever. Can't do that. Another example, do different work groups differ in number of supportive behaviors? Say I'm an organizational psychologist that come to some workplace and they already have certain specified teams. Obviously, it's going to really screw up that workplace if we just randomly place people on different groups or teams, right? So sometimes we go into some sort of environment and there's already kind of samples or groupings predetermined just based off the nature of that environment. Third example, are there differences between 20 and 40-year-olds in reaction time and cognitive flexibility? So this is an example of two dependent variables. Um, Again, we can't randomly assign someone's age, right? I could tell you you're 50, but if you're 25, that's not going to mean shit, right? like that your age is what it is. So we can't just randomly assign that. And there's not really a control or comparison group there either, right? Like compared to whom, right? We're just kind of comparing them to each other. So some examples there. Correlations, or yeah, I guess to wrap up the thought. So the point is, it's an experiment, or it's our best attempt at an experiment when we can't truly control everything, which again is usually the case. Um, Correlations, we already talked about in our last module, so to briefly just refresh on that. These help us to assess prediction, not cause and effect, but prediction. So if we see one thing, if we see X, do we tend to see Y, or what does Y usually look like? Can we predict one of those if we have the other? Yeah, so again, you can depict it with graphs. Actually, like numerically, a visual aid for a lot of people, I think, is a Venn diagram. That's what kind of helped me get it at first. So basically, how much overlap do we have between these things? And so again, here's a graphic depicting the um, basically what the scatter plot looks like for different correlation coefficients. And so you can see as we approach +1 and -1, we're basically approaching a straight line. And so if there's a perfect correlation, basically it means that those things are identical. Because as one goes up or down, the other goes up or down identically. Yeah, and so strengths here can study things we can't manipulate. They can, like age, for example, they can tell us about the way things fluctuate. But the weakness, again, correlation is like causation, like we talked about last time. And so to dive just a little bit deeper to explain that than we did previously, let's say I'm a researcher and I find that motivation is positively correlated with performance. What are the underlying mechanisms that explain this relationship? So let's use a college context. Let's say motivation to learn research methods. Let's say that we find that it's correlated with performance in a research methods class at an R of 0.5. And so, yeah, like again, just a rough example of what that might look like. But basically, as one's going up, the other is going up. So more motivated, performing better. Okay, so what could be happening here on like a deeper theoretical level? Well, for one thing, one could argue that motivation influences performance, right? Or one could argue motivation causes performance. That seems intuitive. If I'm really motivated to do something, it makes sense that I'm probably going to do pretty well compared to someone who's not motivated. Maybe the inverse is true though too, right? Maybe performance causes motivation. Like if you think about getting positive feedback, like if you were on, like if you played any sports or did something like that when you were younger, or in any sort of team environment where there was a coach and they were like giving you positive feedback, saying, "Hey, you're doing a great job." I remember like I played soccer, football, all sorts of different stuff when I was a kid, and that always was kind of motivating to be like, "Oh shit, I'm getting it down. We're doing well. Go team," all that good stuff. Um, One could also argue that there's other outside variables or constructs that are playing a role too, right? Maybe it's effective leadership. So in that previous example, if I'm playing soccer, maybe there's a case to be made that having a good, effective coach is going to influence both our motivation and our performance. So we see that those two things are correlated, but it's kind of due to some other extraneous variable that's influencing those things. Maybe it has nothing to do with the coach. Maybe it has everything to do with the individuals, right? Some people just tend to be more motivated and or perform better. We talked about sleep already. Maybe it's something to do with sleep, right? If you didn't sleep and you go to a soccer game, you're probably going to do worse than someone who slept 12 hours the night before. Well, maybe not. That sounds like too much sleep. The point is, right, there's so many different ways we can try to explain human behavior. And so, whenever we have a correlation coefficient, there's really so many things that could be going on. And so that's why we say we can't really isolate that cause effect statistically and things like this. Um, yeah, and so I've shown you these slides before, so I won't spend time on them. I don't know if we showed this one. Um, I'll let you pause it if you want to go through it. I feel like this video is long enough. All right, we'll see you next time.